The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to our September 2025 edition of our AMS webinar and our continuing AMS webinar series. Thank you for joining us today. My name is Joe Anand, and I'll be joined by Don LaCourse today, who's going to be actually doing most of the work. And I'll be in the background listening to your questions. Today we're jumping into 3-axis machining. So we're starting out with machining 3D models with 3-axis in our CAM product standard. We're jumping in with the standard, so it's basically the configuration that we lead with, and that's the most common configuration that we sell. And so we're going to be talking about all the different methods that you can use in this configuration. So today's agenda. Before the agenda, some housekeeping here. So use your chat window for questions. The graphic on the right side on the slide actually shows what you will be seeing as far as the webinar dialogues are concerned. So if you have any questions, you can just type it in. I'll be in the background listening and watching. And while Don is running the demo, we could stop him if necessary, or I can answer the questions in the background. We want to keep it as interactive as possible so you can get the most out of this webinar. And as usual, the recording of this webinar will be made available and sent out to everybody after in a couple of days. We'll create that a YouTube video and send it out. Okay, as far as the agenda today, we're going to be starting out with geometry requirements for 3-axis machining, recommended cutting tools. Then we actually jump into stock and setup considerations. How do you want to actually set the operations up, the orientations and things of that nature. And then we'll actually jump into actual programming, starting with the 3-axis horizontal roughing, and then a little bit of esoteric topic here, the step minimization. Many of you might or might not use this, but it's a pretty useful one that Don will be talking about. And then parallel finishing, which is really our main finishing operation in the standard configuration. He'll be talking quite a bit about that. And then also horizontal finishing. Both parallel and horizontal finishing are the two main finishing operations that you will be using in the standard configuration. Then he also is going to talk a little bit about 2-axis profiling, just to show the difference, differences between 3-axis machining operations created and what the 2-axis profiling is going to do, especially in the context of mold machining. And of course, he's going to be talking about cut material simulation, and then finally post-processing and outputting of the G-code. So Don, you want to take it? You want to take it from here?
Sure, I'll go ahead. Hello, everyone. Good day, everyone. I hope you can hear me okay. If you can't, just put a message in the chat window, and we'll see if I have some technical problems or not. Hopefully not. What you see on the screen out here is the part we're going to be programming. It is what you can consider a mold core insert, where it's setting on a plate. This is the insert plate, and the core is machined out of that plate. What you're looking at here is the prototype configuration. I'll be looking at the possible production configuration as well. So just some general points here types of machining we're going to be using. We're going to be doing some initial horizontal roughing. I'll rough this down. We're going to do some step minimization, which actually combines a re-roughing into a horizontal roughing all in one operation. It's pretty interesting. Then we're going to do some 3-axis pre-finishing. So we're going to work it down with a little bit of stock left over, and then we're going to do some additional parallel finishing in both the X and the Y. We'll be looking at horizontal finishing for the walls that are nearly vertical, and we're going to be looking at 2.5-axis profiling as it compares to 3-axis and what we're going to be doing in 3-axis. So we're going to show the difference of the two and why one is obviously better than the other. So let's go ahead onto the demo portion, and let's bring up our part here. Okay, so what I got on the screen here, we got the orthographic views, top, front, right, and perspective. I'm going to go into the perspective view. Okay, and just to look at what I got over here on the layers, we've got mold plates. These are the two mold plates right here. This is our insert with our core. And we've got one surface for a masking surface that's going to mask out these holes so we don't machine them. And we have some section views that we have cut just to get an idea of what the shape of this part in different areas. Okay, so what I'm going to do is I'm going to go ahead and turn off the mold plates. Okay, so we have basically the way mold inserts work. You have two diagonal pins for alignment of the plate, and then you have screws to actually fasten the plate fasten the insert to the plate, the mold plates itself. Okay, so what do we have? The first thing you need to do in any CAM project is you got to get really familiar with the geometry that you're going to be programming, obviously. So what is important with this particular set of geometry? Obviously, you have a lot of complex surfaces in here with some fillets. That's not really nothing that we see here is really a problem with programming it as far as the surfaces up here go. The primary area of concern, and you'll know this, especially if you're a mold designer or a mold machiner, is this parting plane. So we have the core, which extends above the parting plane, and we're going to be paying attention to this transition area right here. And you're going to need to ask yourself as you look at your geometry, where on this geometry am I allowed to have fillets? In 3-axis machining, when you have contoured curves like this or contoured surfaces, it's difficult to get an exact sharp edge. Okay, so you need to find out what is acceptable as far as a fillet. How small of a ball mill can you use to get in there? What's acceptable to the mold design and your customer, etc. So we're not going to be worrying too much about these edges here. We're going to be just including them in the programming of the main body itself. But we will be. You do need to find out what is acceptable for the mold. Now remember, this is a prototype version. Okay, so this edge, you may have some leeway, and you may be allowed to put a small fillet in this edge, which in a prototype production just means this is the inner core. So this edge is going to be the inside edge of the cavity. So you may just have a little fillet in there, which may be acceptable as far as prototyping goes. But we're going to pay special attention to that as we program it out. Now, we do have a little bit of more time than we usually do in the webinar, since we're using the standard configuration. We're going to be going through this relatively faster than we normally would in a professional configuration. So I'm going to go ahead and pop over and show you what this would look like in most likely case in a production scenario. So I'm going to bring over this right here. Now you see that we have the same core insert. We have the insert plate with the core surfaces on top. We have the mold plates here, and I'm just going to hide those. Okay, so what will most likely happen for a production environment for this mold insert is that you really want to get a sharp edge there, because that's what the part requires at the parting plane or the parting line. So you really need to maintain that sharp edge. In order to do that in a production setting, you probably don't want to machine it the way we're going to machine it for the prototype. So what they will probably do is wire cut that shape out. So what they'll do is they'll mount this the mold plate, or this is actually going to be a whole block, okay? And we'll probably wire cut. What they'll do is they'll probably drill a hole right here, since this is not a part surface. They'll probably drill a hole here to feed the wire through, and then they'll wire cut it around. So let's take a look at what that looks like. I'm going to go ahead and hide this. Again, if you got any questions, put it in the questions panel. Okay, so in most likely cases, when they wire cut it, anytime they cut anything in a mold shop, they're going to be cutting more than one. So they always cut in sets. In case something happens to one, they can use the second, or they may do 3 sets. Okay, so to get this sharp edge, in most cases, I have it programmed out, but I'm not going to program it in this. I'm going to program it in the prototype. But they'll probably just machine, on down as if this is a part surface, okay? And they'll just machine past this parting plane right here, which is no longer visible now. So one way they might do it, and the way I'm going to do it in the prototype, I've got a number of ball mills, starting with the 3/8, a 1/4 inch, and a 1/8 inch ball mill. So we're working it down. So one question you may ask yourself, do I want to machine down to this? You can consider this a fixture, okay? Because that's the wire cut part of that mold plate, and your core is going to be mounted on that, okay? So they've got a couple of pins here, which will align it with the core, and then you have some fasteners, cap screws that actually fasten it in place. So if you're only machining one set, then you really want to pay attention to how you're going to machine at this parting plane. You probably don't, you can consider this a parting line, even though it's a parting plane, because you do have a line between the fixture portion and the core portion. So you may not want to have the tool actually run down on this fixture. You may want to maintain the tangent of the ball mill to stop at the actual parting line. Okay, so in order to do that, an easy way to do that is to use catch planes. So you may have seen us do this, or you may have done this for a number of purposes. And in 3-axis machining, every surface that's visible is taken into account when the toolpaths are calculated. So if you have a surface here that's visible, the tool obviously is going to stop on that surface. It's not going to cut below it. As you can see here, we've got some offset curves we're going to use for different tool sizes. So what this is going to do is this catch, or spelled catch wrong, catch 3/8, is the 3/8 ball mill is going to stop on this plane, which means that it's 3/8 of an inch below the parting plane. So it's a 3/4 inch ball mill, and the tangent of that ball mill with this catch plane is going to hold that tangent right on the parting plane. Okay, so you got different planes for different ball mill sizes. So we got a 1/4 inch. Okay, so this is a 1/4 inch below the parting plane. This is going to be using a 1/2 inch ball mill, and then we have another one for a 1/4 inch ball mill. So they're in just different levels, which keeps the ball mills tangent to the parting plane. Now, if you're wire cutting out more than one, which is actually what will happen, you can just ignore this method and just machine down, say, a 1/2 inch below this, like in a horizontal finishing operation, to match this profile, and it'll give you a nice sharp edge right there. Okay, I just wanted to go into that just so you'd understand the different ways you might want to approach this particular insert. So I'm going to go back over to my start part here. So let's look at the different tools, cutters we're going to be using. Let's go down here and we'll just click this and look at the tools. So we have, as I mentioned, we have 3 ball mills. We have a 3/4 inch ball mill, a 1/2 inch ball mill, and a 1/4 inch ball mill. And our smallest ball mill will be the finishing pass, which will leave an 1/8 of an inch fillet down along this edge. Okay. So we got 3 ball mills. We have a flat end mill that we're going to use for roughing. And we also have a corner radius mill, sometimes called a bull mill, which has a flat at the bottom, okay, and a corner radius of 125, which is the same radius as the 1/4 inch ball mill that we're going to be using. And I know if you've heard us and how we recommend to do different types of operations. In horizontal roughing, we always recommend that you use a flat end mill if possible, because it's going to calculate a lot faster, so you'll get through the actual programming faster, and it's actually going to cut faster. And we recommend that you don't use a ball mill for roughing or a corner radius mill for roughing, but there's always exceptions. In this particular case, in order to get what we want right here along this edge, we are going to use a corner radius mill. And if you've also been to our webinars, we try to show you different ways of using different operations, which may not be readily apparent to you. So what we're going to actually do is we're going to use a horizontal roughing operation with a corner radius mill in order to get a perfect fillet along these bi-tangent areas here. And that's something we're going to show you in detail. Okay, so those are the cutting tools. And let's take a look at some of the preferences that we have set. Stock, we've just set some colors for our stock material. And we have edge is going to be highlighted, which you should see the edges. Cutting tools, we just have colors for those. Standard feeds and speeds. We're not going to be actually recommending any feeds and speeds. If you've seen our webinars before, we're not ever going to tell you what feed rate to use for a particular tool, because that is something that you have to know specific for your machine, your cutting tools, your materials. So all of these feeds and speeds are going to be the default values. For the machining, we're going to do a part sampling resolution set to fine. And we got a minimum arc radius. We don't have any really large arcs here. Output control, we're going to be outputting arcs. Okay, we're going to turn that off. For tool path, we just have different colors set, and we have the thickness for the tool path set so we can see it very well. For simulation, we've got the simulation accuracy set to fine, and we got the simulation tolerance set to 5,000. Okay, and then we have a stock model display transparency. We have that set in the middle between opaque and transparent. User interface, all these are pretty much the standards here. Post-processing, that's pretty straightforward. Okay, so let's go ahead and get started. Now I actually have another screen over here that I have this part fully programmed on, so I'm going to be referring to that as we program this part. So for any CAM operation, as I mentioned, when you start, get to know your geometry. We went over the geometry here for this part. In your geometry, get to know what these radiuses are, because your finishing ball mill will need to be that or smaller radius. Okay, so we got a number of radii here, and we got a number of section curves that we've cut just so we can. We looked at the drafted angles here based on the sections, so you can cut those using Rhino's sectioning commands. So we got the section curves, and we're going to start over here from the program tab. And again, I want to point out, if there's something that we didn't cover that you want to know, just put it in the questions panel. So the first thing we're going to do is we're going to do horizontal roughing to remove, this is a prototype insert block. So this is all one block. So we got to remove all the material around this core. So we're going to be going with horizontal roughing, 3-axis. And the operations I'm using are the operations is available in the standard configuration. So we're not going to be doing anything that you cannot do in the standard configuration. So for horizontal roughing, for the control geometry tab, we're not going to select anything. As you know, if you're familiar with our CAM products, there is a certain amount of intelligence built in to the toolpath algorithm, so it automatically knows where the part is. Okay, and actually I didn't set the stock, so let's go ahead and cancel that a minute. Let's go to our stock, and we're going to do a copy model bounding box so we can see the dimensions of our part. And that is 28 inches by 27 by 13.09. So we're going to just put a little bit of material in here, which is just 0.25. Okay, just to extend that a little bit above this top area right here. So we're going to pick OK there. And we're going, since we did add material, we're going to go ahead and align the stock. And we're going to align it with the bottom of the insert block so that the extra material extends above the part on the top, and it's going to be centered. Okay, so we'll pick OK there. So here's what our stock looks like. Let's go turn that off for now. Now let's go back into our horizontal roughing operation. As I mentioned, we're not going to select anything here. It's going to automatically calculate all the material that it can remove based on the part material, the stock material, and the cutting tool that you're going to be using. So for the tool, we're going to be using our flat end mill. Okay, so it's a 1-inch diameter, 8-inch long flat end mill that we're going to be using. And we're going to skip the feeds and speeds. For clearance, we're just going to use the default clearance plane parameters, automatic. For the clearance plane definition, we're going to set the automatic. And for the cut transfer method, this is where the tool retracts to change directions. We're going to leave that set to the clearance plane. Okay. Now for cut parameters, we're going to leave it a tolerance of 10 thousandths, and we're going to leave some 25 thousandths of stock material on the part. So we're going to have multiple cut levels, but no cut level will come closer to the part than 25 thousandths. Okay. And we're going to be using a offset cut pattern. So the roughing will do successive offsets of the shape of this core region. We're going to be allowing a mixed cut direction. So the tool can go both right and left in both directions. We're not going to limit it in a climb or a conventional configuration. We're going to let it mix. We're going to start machining on the inside, so it'll probably start on the inside up here and work its way down. And we're going to set a step over of 25% of the cutting tool, which is 1 inch. So the step over is going to be 1/4 of an inch. Okay. And we're going to leave corner cleanup. We'll leave that set to none. And let's see what else we got here on the cut levels. Okay. For cut levels, the step down is going to be 50%. So it's a 1/2 inch. So this is relatively soft. It's not treated steel or anything. So this is relatively soft material. So we're going to, for the main step down, is going to be 50%. So here is where you can set your step minimization. If you check this box here, you can give it a secondary step down. So if you look at the picture right here, the dark orange, okay, or sorry, the lighter orange is your initial 50% step down. So you have a large step, okay. It's called DZ. and the darker orange will be your minimization. So what it's going to do is it's going to start cutting it at 50%. It's going to go through the entire cut at 50%. Then it's going to come back. It's going to cut additional levels at 25% using the same tool. So the first passes will be at a ½ inch, and the second step minimization pass will be at a ¼ inch, 25% of the 1 inch diameter. Okay, and we're going to do a depth first cut pattern, and this is a critical area here. If you're familiar with our product in roughing, horizontal roughing, you know that we can clear the flats, we can tell it where to start, where to stop. I'm purposely not selecting anything here. So what's going to happen is it's going to take everything it can down to the parting plane, but it's not going to clear the parting plane. What you don't want to do is you don't want to have that sharp corner of that flat end mill anywhere near this parting edge. Okay, so we're going to do that in a separate special circumstance situation. Okay, so the cutter is not going to clear the flat, so there's going to be material left here at the bottom. Okay, engage and retract. We're just going to leave it in the default values, helical entries. And let's see what else for advanced cut parameters. We're going to allow it to find arcs. This is not really critical in the roughing, but we'll leave it. We'll leave this set to 02. So arc fitting should be recommended to be 2 times your cut tolerance. So our cut tolerance is 10 thousandths. So our arc fitting is going to be 20 thousandths tolerance. Okay. We're not going to do any toolpath optimization. Let's go ahead and generate that. Now, while I'm generating, it's a good time to think if you have any questions, you can type them into the questions panel while this is calculating. And this will take a little bit of time. Any questions, Joe?
Nothing yet,
Okay.
but maybe you can talk about tolerances and generation speed. Maybe I can talk about it.
Okay.
Well, it's done, but one of the things you can do to speed up, if you're doing what if scenarios when you're machining, I would recommend setting tolerances, slack tolerances and generating it. Things will go quicker. And then once you're ready, once you got the program all figured out and exactly how you want it to do, then you can come back in with your final tolerances and do the final programming.
That's a good tip there. Also, what you can do is your step overs. Maybe initially you don't need to be a really tight step over. If you just want to get a good look at what this path is going to look like, you just give it a wider step over, as Joe mentioned, a more lax tolerance, and that'll help speed it up as well. So we got through. Let's look at what this. So I got a number of toggles here. I've got the toolpath display turned on. This is toolpaths that are hidden. I'm going to turn this off just to clean it up just a little bit. And I'm going to look at the cut levels here. So you'll see that the last cut level is above the parting plane. I don't want this roughing to go down to the parting plane. Okay. So we got multiple levels. And then we also have, I'm going to set a property here, a color property. So the color of this operation during simulation is going to be this color right here. Okay. And let's go and do the simulation so you can see the step minimization. Let's go up here. I'm going to turn the toolpath off for now. Okay. And let's go ahead and make this as fast as I can just to get through that. And I'm going to set, if you want the colors, we set specific colors to each operation. If you want to see those colors during simulation, you need to set this to MOP. MOP stands for machining operation. Okay, so now we're going to, so it's working its way down. So it's doing out here, working from the outer end, is doing the 1/2 inch, 50% step down. And let's go ahead and change something here. Okay. And let's change something else here. Okay. So now you can see. So it did, what it did was it did 1/2 inch step downs out in this area here. When it got to the part, it did an additional 25% step down with the same tool. So it's like a roughing operation, and I mean it's like a re-roughing operation at the same time as it does the main roughing operation. So you can work it down further, and you can adjust that to whatever you want. It's set to 25% here. So each one of these step downs is 1/4 inch instead of 1/2 inch. So this comes in really handy if you want to do a re-roughing and it's okay to use the same tool, then you can do the step minimization. And on the opposite side of what the outcome will be is that not only does it add additional step downs here, but it eliminates from you having to do all of it in one 1/2 inch step down, which means you would have to come back in maybe with another operation, maybe with another tool to work it down. We're doing it all in one operation using the step minimization options that are available in the horizontal roughing. Okay. Now, we're going to do a series of parallel finishing operations. So we're going to do one parallel finishing just to get it worked down some. So let's go over here to the program tab. We're going to do a parallel finishing. Okay. And if you'll notice, we have a set of curves here, closed offset curves. These are offset from the parting line here. So what these are going to do is we're going to select this one, which is 3/8 of an inch away from the parting plane. Okay, so that's half the tool diameter. So if the tool diameter is a 3/4 inch ball, this offset distance is going to be a minimum of 3/8. You may want to give it just a little bit more to get that tool all the way down. Okay, so we're going to use that as the containment area. So in contrast to the roughing where we didn't select anything and we let the cutter and the algorithm just figure it out for you, in this we want to contain it. So anything that you select in a 3-axis operation on the control geometry tab is a containment. So it's going to contain the tool path to a certain area. So that's what we're doing here. So we want to do a parallel finishing operation. We're using our 3/4 inch ball. Let's skip over here. We're going to be using this to default clearance, cut parameters. Now, one good thing, the difference between parallel finishing and horizontal finishing. In parallel finishing, it's really fast, okay? So we have a relatively complicated core model here. We're going to have relatively tight tolerances, okay? And okay, I guess that's okay. I'm not sure why I have that set there. We're going to put the 0.001. So we got 1/1000th tolerance, okay? And we're going to use a mixed cut direction. It's going to start from the bottom meaning if you're looking down on it. Let's look down on it. Okay. So bottom meaning this is the bottom and this is the top. And we're not talking about the bottom plane, okay? And we got a step over, a pretty general step over of 25%. This is just to remove a good bit of that material, okay? For Z containment, okay, Z containment, we don't really have anything there. What I was going to say, the difference between parallel finishing and horizontal finishing. In parallel finishing, the tool paths are projected down onto the XY plane, okay? So we're looking at the XY plane right now. So the parallel finishing is just going to be a set of parallel lines projected down onto the part. And that can be done pretty quick, within the algorithms that we use. For the horizontal finishing, those are actual section cuts through the part. So they take a little bit more time to calculate those sections in order to find out where the tool paths lie. So we're going to be use parallel finishing whenever possible, horizontal finishing when you really need to finish on a sidewall that's more vertical than it is horizontal. So here we're not going to be setting anything here. You could use multiple step downs, parallel finishing. You could, as in the horizontal roughing, where you can combine a re-roughing with a roughing, and parallel finishing, you could combine this into a pre-finishing and a finishing just by adding multiple step downs, where it would step down automatically until it gets to the part itself. Okay, but we're going to be doing it in separate operations, okay, because we want to use separate, different, successively smaller tools. Okay, so we don't have anything here set for the entry and exit. We're just going to be using a linear entry, and we're going to do a with straight cut connections. You see this little picture here, the cut connections where you connect one linear path to the next, to the next, to the next. Okay, advanced cut parameters. We do want some arc fitting, and the cut tolerance is 1/1000th. This really can be a little bit larger tolerance if you want. For instance, we could set that to probably 0.5, since this is still a pre-roughing, 0.5. And then for the arc fitting, we can set this to 1. Okay, which is 2 times the 0.5. Okay, so let's go ahead and generate this. And you saw that was very fast. That's why you want to use parallel finishing whenever possible. So let's go back up into the isometric view. Okay. So you'll see that we did, I think this is a 1/4 inch step over, okay? And it went down and stopped at our control geometry curve. As you can see, it's a little bit extra. You can tighten this up. You don't want it to be right here, but you want to give it a little bit of room just for tolerances, okay? So let's go ahead and simulate that. Let's see what this color is set to. Okay. Let's turn the toolpath off. Okay. So what you'll see here, this is just the first pre-finishing pass with the 3/4 inch ball mill, working its way down. Okay. It's leaving this extra material that we left on top of the parting plane, which is what we want, because we're not going to come in with a separate operation and handle that. So this is the first parallel finishing pass. So what we're going to do is we're going to do another one. Okay. And for this one, a second, I'm looking at my other screen here. Okay. So for this one, as I mentioned, we have various offset curves. So for this one, we're going to be using the, let's see what that is. We're going to be using the 1/2 inch ball mill. So this inner curve right here is going to be a 1/4 inch, at least 1/4 inch, maybe 0.3. Okay. So let's go ahead and select that geometry. Okay. So this is going to be our containment for this parallel finishing operation. We're using a 1/2 inch ball mill, same feed to speed, same clearance, cut parameters. So we're going to leave it at a tolerance of 1,000th. Okay. Stock in this case is going to be 0. So this is our first finishing operation. And we're going to use a mixed cut direction. Again, we're going to start at the bottom and work its way up. And for this step over, we'll set that as a tighter step over of 5%. That's 5% of a half an inch. Z containment, nothing there. We'll leave that's all the same as the first. Here, we want to set this to 2,000. And let's generate that. So that was pretty quick. So now, as you see here, we've got a second, or this is the first of a set of finishing operations. And we have a 5% step over, okay? And it's contained within that offset curve, okay? And we have arc motions are always dark blue by default if you use the default colors. Let's turn, okay, that's fine. So the dark blue are arc motions. Those would be GO2, GO3 motions in the G code when you post it out. The light blue or cyan color are linear motions. Okay, so let's go ahead and simulate this. Let's turn the toolpath off. Let's check the color. Okay, let's run that. So it's working its way across. Again, if you have any questions, put them in the questions panel. So it's just working its way down. Okay. These light colors here, those are just the simulation silhouette colors that we had turned on. This is not a gouge or anything. So as you see, we've got a finishing pass on the contoured areas of the part, and we have a 1/4 inch radius down here. And again, this is extra stock that we're leaving there until the end. So we have a 1/4 inch bitangent radius right now at the bottom around this, all the way around. And one thing you'll see here is you got a good finish over here, but not such a good finish here, and that's dependent on the cut direction of the parallel finishing. Okay, let's turn this on just to see. Okay. So in the direction of the tool, in the direction of the tool, you'll have more of a more of a correct fillet, and in the 90-degree direction of the tool, you'll see some cusping till you get down to your finishing operation. So this is our first finishing operation. Let's go ahead and do another one. Okay. So on this one, we're going to be using the same tool, but we're going to be going in the same direction with a smaller step over. So this is the first finishing, and then we're going to do another finishing with a smaller tool. So for this tool, actually, yeah, for this tool, we're going to be using a 1/4 inch. Okay. And for the cut parameters, tolerance is set to 1,000. Now, one good thing about using the parallel finishing, it's a very fast operation, so you can tighten these tolerances up, just for a what-if situation, because it's not going to take a whole lot of time for the parallel finishing. So I have a 1,000 set, and let's go over here and see what the other parameters are. Stock is set to 0. This is a finishing operation right on the part. We have a mixed cut direction. Start side is the bottom. The step over is 5%. Okay, so we're using the same step over, but we're using a smaller tool. So it's going to have more material is going to be removed. So for Z containment, we're not doing anything there. Entry and exit with all defaults. Here, we do want to use arc fitting. So that's 1,000. So the arc fitting 2. Okay, a minimum of 2. You could go higher if you want. Let's generate that. Okay, so we got some problems here. Let's see what goes on here. Okay, let's turn this off for a second. I did not select my containment. So this is a 1/4 inch tool. So it's going to be using this one here. Pretty fast. Okay, so it's similar to this one. Okay, same with a smaller tool. So you have a tighter step over. So there's our real tight step over. And let's go ahead and simulate. Let's turn the toolpath off. And we're going to go play. And again, it's working its way down. If you don't want to wait, you can pause it and then hit to end. And it'll just skip to the end of the simulation. So this will take a little bit of time to get to the end. Okay, let's take a look at this here. Our colors are probably not set. Okay. So there is our third parallel finishing operation. Okay. Now, these little things you see here, those are just artifacts in the simulation. They're actual arc motion. So that's going to be nice and smooth on the part when you actually cut it. And you'll see down here, now we have which tool did we use? We used the 1/4 inch. So this is a 1/8 inch fillet down here. And still we contained it so we not cutting any of this extra stock material. I think you'll see what I'm getting at here is that we're working it down, okay, with a smaller tool. And then we're going to come back in at the end with a finishing operation to not only clear this parting plane, but also get a really nice fillet here. Because if you think about it, these contoured surfaces, they're not vertical. This draft on these, you have a draft here. This one here might be vertical, but then you have the curved ones, which are not vertical. So this fillet is really a bitangent arc. By bitangent, I'm referring to the fact the ball mill, when it's cutting this bottom edge, is in contact with both the part and the parting plane. So that means that you get an exact fillet around this edge. That's why we're leaving all this material at the bottom. Okay. So just a look around here. Looks pretty good. Okay. Now, one thing you'll notice, you're wondering why I cut that hole. I didn't have my mask surface turned on. You can mask that when you do the roughing. We'll just leave that off for now. Okay, so what did we do? We did the horizontal roughing in levels. We did not clear the flat area. We left the flat area with stock on it. and that's with a 1 inch. The first parallel finishing is with a 3/4 inch ball. The second one is with a 1/2 inch ball. And again, for the 3/4, it's using this offset here, which is probably 0.4 or at least 375. The next one is with a 1/2 inch ball mill with a quarter inch offset, or 3.3 probably. And then the next one using a 1/4 inch ball with a 1/8 inch offset curve. Okay. Now, here's the interesting part. Well, actually, I got one more finishing. We got one more finishing. So what we're going to do here is we're going to use the same control containment boundary, and we're going to use the same 1/4 inch ball mill. Everything's going to be the same. Let's see what else we got here. Okay. We're running it, instead of along the X, we're going to run it at 90 degrees, which would be along the Y, or actually, I think this was the X. So we're going to be running it in the opposite direction. Okay. Let's go set that to 90. Okay. So everything else is the same. This is going to be 5%. Everything else should be the same. So with parallel finishing, you always want to go one parallel finishing in one direction, then another parallel finishing in a 90 degrees from the first one. So we're going in one way, and then we're coming in this way to get a better finish on the part. Let's go ahead and simulate that. Turn that off. Pause to end. Again, if you got any questions.
There's a question here, Don. Is there any way you can automate turning all of these on and off, which, these masking surfaces? I don't believe so, but
no. And you really, I would recommend that you get to know your masking surfaces so that you learn, what needs to be on, what needs to be off, so you have control of them, in your mind, so you understand really well what they're doing. But I don't think there's a way to automatically do it based on, an operation. So here we got it done. It's finished. So this is our finishing toolpath. Now, let's do this bottom area. Now, I do have one horizontal finishing operation, but it will take some time to calculate, so I'm not going to do it, but I'll just show you real quick. So we're doing consecutive parallel finishing. We're parallel finishing along the X. We're parallel finishing along the Y direction, and we're going to do a horizontal finishing. We can just set the parameters, but I'm not actually going to cut it. Let's see what it's set at. So on this one will be the same. There, tool, be a 1/4 inch. Everything's basically the same. Tolerances, cut levels. It was set to 0.01. We used a distance, 0.01, which will give a nice finishing in elevation planes. So for the horizontal finishing, it's cutting the part in sections along the parallel to the XY plane, and that does take longer than just a parallel finishing, which is a projection toolpath. So we're just going to save that, or actually I'm just going to cancel it because I'm not actually going to simulate. That does take a little bit of time. So let's go straight into what are we going to do this bottom area. So we're going to be doing a horizontal roughing. And you may ask why you're going to do roughing. I'm going to explain that to you. So for horizontal roughing, okay, we're going to, first off, we do want to put the mask on. Let's save that a second. Okay, so we don't mask those holes. You should have that masking on anytime you do roughing. And if you're going to do any finishing here, obviously you don't want to go down in those holes. Okay, so let's go back over here, the horizontal roughing. Okay, so we don't really need to select anything. This is similar to what we did for our first horizontal roughing. Okay, so for the tool is going to be our corner radius mill. So this has the diameter of this corner radius mill is 375. So you got a corner radius of 125, which is the same as the 1/4 inch ball mill that we used. Okay, and it's have a flat area on the bottom of the tool, which would allow us to clear this area out. Okay, so what we're going to do though is we're going to go over, get past there, cut parameters. Let's look at cut parameters. Okay, which just leaves that set a little bit slack for now so we can get to it quicker. And in this case, we're going to use a linear. It's just going to cut back and forth. Okay. So you might ask yourself, well, isn't that going to leave some cusping or some tool marks along that edge? No, because we're going to be using a cleanup path. So if we look at this little picture in the dialog, okay, so we're using a linear cut pattern, so it's just going to go back and forth, but we're going to use a cleanup path. So you'll see that it added a circle here. So consider this to be our core area. So what's going to happen is it's going to do parallel cuts, and then it's going to go and do a really nice cleanup around this parting plane. And that cleanup is going to be an accurate bitangent cut. In other words, the 1/8 inch radius on this cutter is going to be exact bitangent cut at this edge. Okay, and to also make it a little bit better, we're going to go over to the cut levels, and we're going to set a distance of 0.01, and we're going to tell it to use the distance as specified, so it's going to be exactly that. In roughing, if you don't use as specified, the actual last level might not be what you actually entered. It's depending how it calculates it out. So we got it set as specified. We're doing depth first, and here's where we're going to get interesting. So we're going to set a top. We obviously don't want to, this is not a re-roughing, okay? This is just a straightforward horizontal roughing, okay? So if I didn't use any top limitation, it would calculate the entire block, and we don't want that. So we're just going to set this to a value of 4.01. So 4.01, basically, if you think our axis here, our origin here, 4.01 is going to take that. That's a lot higher than I wanted. Let me save this a second. Let me take a look. Okay, that's what it was. So I didn't put my work 0 in there. Let me put my work 0 in. Okay. So here is our origin. Okay. And looks like I'm going to have to redo these. Well, maybe not. Okay, I'm not going to recalculate those. That'll be fine. So our horizontal roughing node, we're going to go back into the horizontal roughing. Now, even though those are flagged, we already have it simulated. So if you're happy with the simulation for now, you don't have to go in and regenerate those. So we're going to leave it like that for now. Go back into the horizontal roughing, go into the cut levels. So for the top is going to be 4.01. Okay, and if you look at that, it should be a little bit above this plane right here. So for the bottom, we're going to leave it set to 4. Okay, so 4.01 and 4. And here we're going to use the clear flats. So what's going to happen here is that the flat of the corner radius mill is going to clear this flat area. The radius of the corner radius mill is going to finish this bitangent edge all the way around because we had the cleanup pass set. So let's look at what else we got set here. Okay, I think all that's okay. Advanced cut parameters. We do want to use some arc fitting. So that's 2 times. Let's see what we had for control or for cut parameters. Okay, this is finishing, so we're going to tighten it up. Typically, your default tolerance for a horizontal roughing will be 0.01. We're going to make this 0.001. Okay, and we're going to have this set to 0. So we're using a horizontal roughing as a finishing operation. And if you've worked with our product a while, you'll know that there's a lot of different ways to use these different operations. So there's a lot of different things you can do. So we're using a horizontal roughing as a finishing, but not only as a finishing, but we're using as a I guess you could call it a pencil trace operation which is a higher level operation in the Pro configuration, but it's going to figure this out using a horizontal roughing operation. Okay, so it looks like all that is set. Good. We got the cleanup pass set. Let's go ahead and generate that. Now we're running just a little bit over, but we're going to be done here in just a minute. Any questions, Joe?
Not. I mean, I've answered most of it,
Okay.
so
Okay.
nothing you need to talk about.
Okay. I want to get through this calculation of the horizontal roughing because that's the key part. It may take a minute.
Outputting post process at this point while it's doing that.
Yeah, we can post it out, I guess.
It's done, I guess, or no?
Yeah, it's done. So you'll see what it did is it looks like I had that as an offset. I meant to do a linear. That's probably why it was taking longer. I wanted a linear path, but I'll leave it at an offset path. But what's happening here is the flat of the tool. Let's go ahead and look at also, I want to look at this. So what you see here is we got 2 cut levels. This is our top, right? The 4.01, I believe it was. And this is our clear flat. So it's cutting in one level to get most of the material out, and then it's coming in doing the clear flat to get on the parting plane, but also, excuse me a second. But also a cleanup path is going to do this by tangent. Let's go ahead and simulate that. Zoom out just a little bit. So here it's working its way in. And again, this is the finishing pass, so that is our parting plane. And it's working its way in, clearing out all this extra material we left. Okay. Sorry, that was the first dropping. This is the actual parting plane it's cutting now. I think that is like an extra 10, 15 thousandths at the bottom, I believe. So it's cutting right up, and you may see it at the end. It will do one pass all the way around. It looks like it's working its way around now. Almost done. I could skip to the end, but I wanted you to see this simulation. So now it's going around, looks like it's doing its cleanup pass. And let's set this. Okay. So now you see you have a really nice tangent all the way around. So that's a very good example. If you do any kind of mold, you know that, everything else is easy till you get to the parting line, and then you got to, have special consideration when you cut that parting line. This is not, in this part, it's not so much of a parting line, but it's a parting plane where it intersects with the mold core itself. So Joe, I think that's it. We're in a little bit over, but not too bad.
Yeah,
no other
we
questions?
kind of skipped on a few things there. We kind of skipped on the don't have access and posting and things like that, but
yeah,
I think we can pick it up on the next webinar.
Yeah, I can
so
just
we
mention
run a little bit over.
I can just mention the
Go ahead.
profiling. If you haven't done a lot of molds, if you're new to this, you may think, well, why don't I just put a profiling operation around there to clean that up? Well, the reason is that it's a bitangent. It's a contoured surface down. You have a contoured surface here. You got a flat surface there. Just putting a profile is not going to get this cleaned up the way you want it. So we did it actually the way that you really want to do it, and that's with the roughing. Okay, if you guys got any other questions, we're going to be sending this video out in a couple of days. If you have any other questions, just respond to us at support@mecsoft.com, and we'll answer those questions. Also, if you want the part files, we can send you those as well. Okay.
Yeah,
thanks,
and also
everyone.
if you have any other suggestions on what you want us to do on webinars, anything specific you want to see, please go ahead and send that as well. So we'll be happy to entertain those. Thank you. Thank you all. Take
Bye-bye.
care and see you next month.
Take care.
Bye-bye.